So, hi people, welcome back to room 1 of DebConf 21. Our next talk is by Maximilian Wilhelm and is titled Contemporary Networking Configuration with ifupdown-ng. Max is a senior network engineer at SAP who also moonlights as a senior infrastructure consultant. He likes Linux and open source and has a soft spot towards networking, IPv6, and routing. Over to you, Max.
Thank you. Good evening, everyone. And let's dive into a little bit of networking. So what we are talking about today, who is who, I've already been introduced. Why a new network configuration suite? What is it and what to be expected for the future? So first to the why. The Network Service Association community found a while ago had an opportunity to set up some sites for a customer. Some other vendors previously failed to get a setup running, but left some hardware which could not be changed because the budget was tight. And basically, these were UBNT edge routers, the big ones, but with an ancient Linux kernel, and those had to be used as a CPE. So a lot of sites, somewhat interesting or difficult network environments, and this had to go live now. So the idea was, okay, we have these boxes, it's some shiny hardware, let's try to get a decent Linux kernel running on it, and let's see how we handle the network configuration. So a lot of space wasn't available in the images, so the images should be small. So Python was out, Rust was out, so we want to stick to a low footprint. Alpine had to be decided beforehand and had to be ported on the boxes, but then we still needed the network configuration part. So what was out there at the time? Basically the IP route 2 stuff, which directly talks netlink to the kernel, where you configure stuff manually, but it's not nice to be automated. You would have write shell scripts. That's not cool. In the ifupdown universe, there is the classical ifupdown-1, which I guess everybody knows when using Debian, and ifupdown-2, which is a rewrite, basically not a fork, it's a complete rewrite in Python from the Cumulus folks. Then there is a NetPlan universe, NetworkManager, systemd networkd, Red Hat, etc., etc. So systemd networkd is quite current approach, but was out because systemd does not run an Alpine because of the musl libc equivalent. So this was not an option. NetworkManager isn't great for server setups. NetPlan is a total different thing, etc. Okay, so a closer look to the ifupdown universe. As I said, ifupdown-1 is used in Debian and a lot of derivatives for decades. Alpine is using it for years too, as part of BusyBox. It's written in C. It's monolithic. It can be extended by touching the C code or putting extension scripts in etc network if whatever D, like the VLAN, the bridge stuff, etc., is added on top of it. But it's not so flexible and has some shortcomings, like the config file is evaluated from top to bottom and cannot handle dependencies, etc. So the Cumulus folks, now bought by NVIDIA, invented ifupdown-2 some years ago. It's available for Debian and derivatives as packages. It's maintained within Debian. You can install it just by typing apt install ifupdown-2, and it should work. It's written in Python. It's modular. It's easy to extend. You can write add-ons. You can place them in USR share ifupdown-2 add-ons and be happy. And upstream is communicative. So they accepted a lot of add-ons I wrote. But for this approach, it's too big because of the Python requirement. Okay, so some opinions led to discussions about what to do. Some Alpine developers already wanted ifupdown done right. Some Debian people were looking for this too, as I've heard. And of course, we needed something like this to support our customer. And if it's something like ifupdown done right, it would be nice because it would be a drop-in replacement. So what did we want? Would be cool if our solution would be compatible to ifupdown-1 and ifupdown-2 to be the drop-in replacement I mentioned. It would be nice if it had support for modern Linux networking features, like stuff like VRFs or VXLAN, etc. I once tried to configure VXLAN interfaces with ifupdown-1, and I guess I would have to hack the C code or the Alexa, and then went on to ifupdown-2. It should be modular, easy extendedly design. So if something cool new feature comes up, it should be easy to edit and not required to hack the core code. And it should have a small footprint. Okay, what did we build? The architecture of ifupdown-ng is basically has two parts. The core is written in C. There is the config parser, or the Lexa part, if you want to call it that way. It will read the etc network interfaces and all referenced files which are included there, will digest it into chunks relevant as we see fit. I will go on into that on a bit. And we introduced a compatibility layer to be compatible with older implementations like ifupdown-1 and 2, and transparently map some things we thought might be better be otherwise. And while we're at, we try to fix some bad practices where we can. And all this happens in a way that we are transparently doing that and are being compatible with the old stuff. We introduced a dependency resolver. So we read the whole file, and then we build a dependency tree to know, for example, that we have to set up the physical interfaces, the bond on top, a VLAN on top, and maybe a bridge on top, and do that in that order and deconfigure it in the backwards order. And this is not dependent on the order in which the interfaces are written into the configuration file. So this is something we as a software package should be able to do, and we built that. The executors are responsible for doing stuff. They are called from the core. This currently are shell script, but could be written in anything you like, basically. So Perl, Python, REST, Go, whatever. They are responsible for doing stuff and creating, setting up, tearing down interfaces, tunnels, whatever, configuring IPs, gateways, and putting all together as required, and are currently installed in the given path on an Alpine box. Maybe this is something which would have to be discussed on a Debian side. I'm not sure what the current path for this are in the Debian world right now. So to dig a bit deeper into the semantic vocabulary, we have been inspired by ifupdown-2. The folks at Cumulus invented some new naming for attributes for interfaces, and we added a mapping for the old school terms to ours for compatibility. The basic idea is we have something like a scope in the naming. So non-default stuff, like default stuff being IP addresses and netmask and gateway, etc., are being prefixed, like the DHCP host name or the tunnel mode, to be explicit on what is configured there. That's something we can easily map. Stuff which is commonly mistyped, like the point-to-point IP address, got a new name. The old one obviously works too. And the VXLAN service node IP, I guess it's called from ifupdown-2, is called VXLAN remote group, for example, because it's a multicast group. So the idea is that clearer terminology leads to cleaner code and configuration files, and thereby making and keeping etc network interfaces friendly to read for humans and for computers. If query got a -P flag where you can see what ifupdown-ng thinks about the configuration. So what's the result of the mapping we do internally and the logic we process. And we have extended documentation for every feature we have and for every, scope we have. So I think there are 10-ish interface dash something man pages for bonds, VLANs, bridges, VRFs, etc., which I guess makes it easier to use than the current implementation, where you sometimes have to search for what are the options which can be configured. A word on dependency resolution. As I said, we try to figure out what to configure in what order. And the left example configures a bond, LHCP bond, over two interfaces and the bridge on top of that. And as you can see on the right side, we build the tree or the graph based on these configurations by ourselves. So we have to, or we know in what order to configure stuff, like ETH0, ETH1, configure them to a bond, and on top configure the bridge in that order, so all interfaces are present when we want to configure the next step. Current features we support are basically, I think, all what ifupdown-1 can do. Correct me if I'm wrong there. So we configure static addresses, point-to-point interfaces, bridges, DHCP, what classical stuff is there, PPP, tunnels, VLANs, etc. And on top of that, some arcane stuff like the Batman Advanced Mesh Protocol, because I need it for Freifunk, VLAN Aware Bridge support, dummy interfaces, simple MPLS activation, like please read MPLS labels on that interface. The Debian East tool integration is possible here too. The virtual Ethernet interfaces, like the virtual network cable, if you will, within the system to connect two VRFs or two network namespaces, VRFs itself, VXLAN, WireGuard, and Wi-Fi clients are possible today. So a lot of features. Who is using that? Since Alpine 3.13, it's included in Alpine, and it became the default network manager. There have been very few complaints, so it seems to be a drop-in replacement for the default configs. In Alpine 3.14, there have been some updates, and it's still the default, so there was no need to roll back. What's the future? Short term, the idea is to be more compatible with ifupdown 2 and, well, yield more inspiration, and have the option to check the running config against the configuration on disk. This is something what ifupdown 2 can do today with ifquery --check. So it tells you if those configs are in sync, reality versus what should be. This is the first step to having the option to reload the network configuration with minimal impact, like not doing systemctl restart networking, like tear down everything, bring up everything again, which is impacting, obviously. The idea would be to do the minimum required changes to get the current state to the state which is in the config file, which is highly relevant if you want to do automation, like I do with the Freifunk backbone, for example. Currently, we have interface-wide execution, which is a problem if you have some interleaving dependencies. So the idea is to have phase-wise execution, like create all interfaces if required, like tunnels, etc., then pre-up all interfaces, then up all interfaces, etc. This will be a little bit of hacking. The idea is to support native executors, like stuff written in C, so you can directly talk to Netlink, and then have some IPC or something to communicate between the core and the executor, but in the same moment not make the shell script a second-class citizen. Let's see how that goes. And it's on the short-term roadmap to build support for managing static routes where required, and policy-based routing rules for interfaces, which might be a quick win too. And maybe today find a maintainer who is interested to maintain ifupdown-ng in Debian. If you are, please find me, speak to me, or come to our IC, which we will link on the last slide. Long-term goals. The idea is to build a daemon, something like systemd networkd, but different. Listen to Netlink events. Did an interface appear? Okay, cool, we have config for it, please configure it, make it up. If a cable has been plugged or unplugged or Wi-Fi got in the range or something like that. And configure or deconfigure interfaces as appropriate as the environment changed. So like UDEV, but for networking, something like that. And for Alpine, there's the plan to integrate this into the OpenRC hot plug run level, or maybe an S6 based init system. So this is for the Alpine part, but left as a reference. And the idea is to speed up the boot process by that anyway. Where can you find it? It's on GitHub. So if you play around with it, find some bugs, please leave an issue or maybe a pull request. And if you want to talk about it, please come to OFTC, to the ifupdown-ng channel there. If you want to maintain it in Debian, please come as well. And that's from my end. And I'm open to questions. Thank you for listening.
Thanks, Max. I'm sure everybody found it a lot interesting. I personally heard about a lot of things that are totally new to me. I should be looking it up.
Okay.
Yes. So we have a question. So somebody says that they're wondering what Alpine is using now due to it being a part of Alpine and Debian. So I don't know if there's enough context there.
I'm not actually sure what the question is. Alpine is using ifupdown-ng as the default network configuration since 3. I think I said 12 or 13. Maybe the question came before I had that slide. I'm not sure.
Yeah, it came towards the beginning. So I guess you have already answered that.
Okay.
Right.
Any further questions?
Let me see. No, that's all. No, for now, that's all. I think people will come to the OFTC, I mean, your channel later on if they want. Yeah.
Please. Yeah.
Okay. Thank you very much, Max. Thank you.
Thank you for having me. Have a nice DebConf.
Bye.
Bye-bye.